Welcome to this video again, where we'll be looking at GCE 2021 proposed solution for pure mathematics with mechanics paper 3. The question we are looking at is a question on center of gravity, and the question reads: in the figure below, ED is a portion of a curve y is equal to 8 minus x squared, and ABCD is a rectangle in which BC is equal to 4 centimeters and CD equals to 5 centimeters. A. Show by integration that the coordinate of the centroid of the portion OADE is 9/10, 86/5. B. Find the distance of the center of mass of the whole lamina OBCDE from the site OE. Now, this is the figure where two shapes are brought together. The first shape is the shape OADE, which is defined by the equation of a curve y is equal to 8 minus x squared, and the second shape is a rectangle ABCD, where the length have been given. AB is 5 centimeters, the difference between 7 and 2 is 5, and BC is 4 centimeters. So we have been asked that let us find the centroid of this first shape from the side OE, and of course from the side OB. So this is a figure we have, and let me assume that the centroid, or the center of mass, of this first shape is somewhere around here, and let's call that x bar, y bar. There are a couple of formulas that we need to recall when we want to find the centroid using integration or by calculus. X bar is equal to the integral from a to b of xy dx divided by a, and y bar is equal to half of the integral from a to b y squared dx divided by a, where a, of course, is the area of that shape. And the area of that shape is simply the integral of the equation of that curve within the limit. So I'll be integrating from x equals to 0 to x equals to 2, because that is the limit where that function is defined. If I integrate this function from x equals to 0 to x equals to 2, I will effectively find the area enclosed by this curve, the y-axis and the x-axis. Now let me go ahead and find each component in this formula. Let me begin with A. Remember, this curve was defined by the equation y is equal to 8 minus x squared. So finding the area under this curve will be integrating the curve 8 minus x squared from 0 to 2. And integrating this function is straightforward, as the integral of 8 with respect to x is 8x, and the integral of negative x squared with respect to x is negative x cubed on 3. Now let me plug in the limits and evaluate this. Let me plug in 2, so I'll be having 8 times 2, 16, minus 2 cubed on 3. Now when I plug in the lower limit, everything else vanishes to 0, and I'm subtracting 0 from this result. So evaluating 16 minus 8 on 3 gives me 40 on 3. So this is the value of the area enclosed by this curve, the y-axis and the x-axis, from x equals to 0 to x equals to 2. Now the next thing we have to look for, I'll be looking for the integral of xy with respect to x. So I multiply the function y by x. 8x times 8 gives me 8x, x times negative x squared, negative x cubed, and I integrate this function as well from x equals to 0 to x equals to 2. Integrating 8x with respect to x will give me 8x squared divided by 2, and integrating negative x cubed with respect to x, negative x fourth divided by 4. Let me plug in the limits, and I'll be having 8 times 2 squared divided by 2 minus 2 raised to the power 4 divided by 4. Remember, when I plug in the lower limit into this expression, it boils down to 0. So 2 squared is 4 divided by 2, 2, 8 times 2, 16, 2 raised to the power 4, 16 divided by 4, 4. So it boils down to 16 minus 4, which is equals to 12. So the value of this integral is equals to 12. So the last component we have to look for is half of the integral of y squared with respect to x. Squaring this function will give you 64 minus 16x squared plus x raised to the power 4. You can expand that and verify to confirm that this is of course, the result. Now, integrating this, of course, is straightforward as well, because I'll be having 64x minus 16x cubed on 3 plus x raised power 5 divided by 5. Plugging in the limits, 64 times 2 minus 16 into 2 cubed on 3 plus 2 raised power 5 divided by 5. Evaluating all what we have here, I'll have a result of 688 divided by 15. Now, we had earlier solved and had the area to be 40 on 3 and the integral of xy with respect to x to be 12. So I can plug this information into that formula that we stated at the beginning, and x bar, of course, will be the integral of xy, which is 12, divided by the area 40 on 3. Evaluating this gives me 9 divided by 10. And y bar, on the other hand, will be the integral, half the integral of y squared, which was 688 divided by 15, divided by the area 40 on 3. Evaluating as well gives me 86 over 25. Hence, the coordinate of the centroid of the portion OADE is 9 over 10, 86 over 5 as required. Now, the B part is that let us find the distance of the center of mass of the whole lamina from OE. So we are looking for the x coordinate of the centroid, because the distance from OE is the x coordinate. So let x bar be that x coordinate of the centroid of the compound lamina, and let lambda be the mass per unit area. Here I am assuming that the mass is evenly distributed in the lamina. So lambda is the mass per unit area. So in order to obtain the mass, I need to multiply the area of the shape or of the portion by the mass per unit area. Now, from above, we had that the area was 40 on 3. That is the area of that first portion, OADE. I'm writing it down because we will need it as we are moving on to find the centroid of the whole lamina. Now, let's come back to the figure. In the figure, remember I earlier said two shapes of known center of gravity have been glued together. So the center of gravity of the shape, or the centroid of the shape, OADE, was at this point 9 on 10, 86 all over 5. And the next shape is a rectangle. And we are finding the centroid of this rectangle from the side OE and the side OB. Now, remember the centroid, or the center of mass of a rectangle, lies at a center, but you are measuring the distance from OE. So, and the distance between 2 and 7 is 5. So from O to B is 7. And now, if I take half of this distance, that will be 2.5. I add it to 2. And then, so the centroid of the rectangle will be 9 divided by 2, because that is 4.5. And the y coordinates of the centroid of this rectangle will be 2. 4 divided by 2 gives us 2. Now, let me assume that the center of mass of the whole lamina is somewhere here, and that should be x bar, y bar. But we are looking just for the x coordinate of this center of mass and not the y coordinate. So I will concentrate on the x coordinate of the center of mass and ignore the y coordinate. Now let me draw a table, and on this table and on the header, I'll be having the portion. Which portion in this lamina am I concerned with? Then I'll evaluate the mass of that portion. Next, I'll find the x coordinate of the center of mass from the side OE. Then finally, I'll find the moment about that x coordinate. Now, let me take the first portion, which will be this first portion, OADE. And to find the mass, I need to find the area of this portion and multiply it by the mass per unit area, since we assume that the mass was evenly distributed in the lamina. So the area of this first portion was 40 on 3 multiplied by lambda gives 40 on 3 lambda. And the x coordinate of G from the side OE, of course, is 9 divided by 10. And the moment of the mass about that x coordinate will be the product of the mass multiplied by 9 divided by 10. Doing the evaluation gives me 12 lambda. Now let me move on to the other shape of known center of mass, which is a rectangle ABCD. And to obtain the mass of the rectangle, I will of course find the area of this rectangle and multiply it by the mass per unit area. And the area of a rectangle is the length multiplied by the width. So the length is 5 and the width is 4. That gives me 20. So the mass will be 20 lambda. The x-coordinate of the center of mass from the site OE will be this distance here, which is 9/2. So I'm adding 2 plus 2.5. That gives me 2 plus 5/2, which is 9/2. The moment of that mass about OE will be 20 lambda times 9/2. That gives me 90 lambda. Then let me now come now to the lamina of interest, which is the whole lamina. And the mass and the whole lamina is OBCDE. And the mass of the entire or the whole lamina will be the sum of the masses of the individual portions. So I add 40 on 3 lambda plus 20 lambda. That gives me 100 divided by 3 lambda. Now the x-coordinates of the center of mass will be x bar. And now the sum of the moment of these individual portions will be 12 lambda. I add it to 90 lambda. That gives me 102 lambda. I have all what I need, so I can take moment now about OE. And I will be having that x bar times the sum of the masses is equals to the sum of the masses multiplied by xn. So, of course, to obtain the sum of the masses, I have 102, and the sum of the mass is 103 lambda. So let me just make x bar the subject and substitute. So x bar will be equal to the sum of mn times xn, which is 102, divided by the sum of the masses, which is 103 lambda. Evaluating, we obtain 153 on 50, or 3.06 from OE. So I've had the x-coordinate of the center of mass of the whole lamina to be 153 on 50. So I hope you have understood. We have come to the end of the presentation. But if you do have any question or suggestions or corrections, please do leave them in the comment section below. And also, if you have some motivating words that can encourage me to keep making videos to help you, leave them down there also in the comment section. Until then, I'm Tata Ernest, and do have a splendid day.